Okay, so before the break, we were finishing up our example from the last week. We started the very first example, looking at all those most basic components we need. These are things we will see in every game engine, or when we make our own game engine, these will include certain requirements, and then others are just sort of conventions that a lot of the ones that are conventions, sort of like where we have that clear separation between initialize and then the main loop. And that goes back to Nintendo. So the mid 1980s, when every single game had to be coded completely from scratch every time, that's the way they started doing it. So pretty much every game engine still follows that convention that those Japanese programmers developed in the mid 1980s. There's all other ways we could do it, but if you follow the conventions, people don't have to learn don't have to figure out the way you did. So if you're making a game engine, people will know if there's an initialize section and then a main loop section. They're separate from each other. Or when you go to a new engine, go to learn a new game engine, you're kind of know off the bat that there's probably a initialize section and then a main loop section that are separate from each other all the way across the board. Sticking with conventions can be very, very useful. And yeah, so now that we've seen that example, one of those conventions is how we write our code. And some of y'all would have seen this in classes already, and because of where prereqs are, some of y'all may not have seen this yet. Something called object-oriented programming. You almost always use that. So we're going to look at that. But a couple of quick notes before we get started. Yeah, I guess I'll start with this. So right now, the Sellersburg School of IT is without a dean. We are between deans. So we have the dean from Bloomington School of IT is serving as our interim dean right now. And last week, he drove down this way, had some meetings and stuff, but when he came down, he brought me a very big box of Oculus Go headsets. It's actually for an event coming up on the 17th. I'm going to show some high schoolers how to do game dev for VR headsets as a promotion, encouraging students, I think from Jeff High and maybe one of the other high schools here close by, trying to encourage them to come to Ivy Tech. And game development always catches people's attention. So he brought him down for that. And I was like, well, I'm teaching game dev this semester. Can I just keep him for the semester? And like, that's fine. So there are a bunch of VR headsets here on campus. So when we get to our 3D stuff, we might do a quick pass at setting that up. Programming the game is the same. We changed the configurations before we get started, and we change how we build the file at the end, change which build package we use. So mostly it's configurations, and then putting the 3D game pieces together is about the same. But there's a bunch of those here, so we might take a look at that here in this class to see how to set up those configurations. It's something you will often see. One thing that took me by surprise, I only ever heard gamers talk about the newest version of VR headsets. They've been around for a long time, but they kind of fizzled out. And then it came back, but only ever heard gamers talk about it. So I thought it was a game console. And when I got mine, I was a little surprised that you can run any software on there. It's just an Android device. So anything that runs on an Android device will run there. Obviously, some of the interfaces made for phones look a little funny floating in thin air. But browser apps work great. You can do spreadsheets and Word documents, and it's a normal computer system. That took me by surprise because I only ever heard gamers talk about it. Obviously, when we do that in class, that would probably be a better day to be at class or just take notes on what those configuration settings would be, because the headsets are all here on campus. Be a good day to be on campus, but it's just a list of configuration settings, so that's a quick thing to write down in your notes and take screenshots of where the buttons to click on, where the check boxes are, that sort of thing. But it also opens up another dimension for applying the knowledge in this course. Did y'all see that email I sent out Saturday morning, I think? I want to start doing VR office hours. It's another setting, or well, look at the screen in front of us. I think everybody in the classroom signed into Zoom because I did that for software development classes even before the pandemic. I still broadcasting across the internet, and then everybody was on campus and just pulled it up on the screen in front of them because it's really hard to read words on an overhead projector, but we're in a computer lab, so just pull it up on the monitor in front of you and then do your example on a laptop or something. Been doing that in our classes for a while, but everybody's on Zoom right now. That's really boring. Like a big black screen with names written on it, no camera. Looks like I'm the only camera that's on right now, so there's not any movement, nothing's changing. But there are ways we can do fully interactive stuff. And that's what that announcement was about. So I tried a few different ones and I decided to give this one a try. I'll go into the Ivy Learn links. So on that announcement I sent out, I sent 2 links. Mozilla Hub, I kept saying it came out last week. The latest version came out last week. The software's been around for a couple of years. The latest version came out last week, so I saw the announcement while I was in the middle of trying different ones. And is everybody familiar with the company Mozilla? Makes Firefox from the second most popular browser right behind Google Chrome. Most people know their name. That's not all they do. So, and then the announcements I sent out, and I copied and pasted the same link twice, so I had to come back and send out a correction on it. So there, this link to this room right here, which it's the same room on this other link. It's just one on one of my servers, so I'm hosting it myself. But their VR gathering places also work in browsers and phones. So it's not just a VR. So you can be on the, some people can be on VR, some people can be on phones, some people can be on browsers. If you get disoriented in the VR setting, you can just pull it up on the VR browser and look at it on a big panel in front of you like a window. But it works in a lot of different settings really, really well. And this is, well, as soon as it pulls up, hopefully it won't take too long. Yeah, go ahead and join the room. They don't have a very good selection of avatars, but in module 3, when we look at graphics, we're going to look at 3D modeling. And I will probably give you my starter one for my human starter files. So they have a, instead of starting with a cube and then making, try and make that look like a human, I have one that has all the correct proportions for a human. And other animals, African elephants, Siberian tigers, gray wolves and red wolves, and green iguanas, and another type of iguana. And like, I spend a lot of time getting some nice starting points, so artists don't have to waste that first hour and a half. So I'll give you some of those. But one for a human, then you can make your own avatar for this. So in VR, obviously, you just moving around, it does the joystick movement, and it's 3D environment, you're walking around. But on a browser, it's just WASD keys. So walking around like a game environment. It's what we would generically refer to as game developers that make things like this. WASD and where's that brand? Oh, in this door. So normal game controls for a 3D world, which everybody that did meet with me over the weekend agreed the phone is certainly the easiest way to navigate. And it's just really, really, on a phone, it's pinch movement, pinch to move, and then swipe to turn, WASD, and then Q and E turn on a browser. So it's an environment where we can mix and match how we interact with it. You got a VR headset, get in that way. Otherwise, hop on a browser or your phone controls. And yeah, everybody that met with me over the weekend and gave it a try agreed that the phone definitely seemed the easiest way to navigate to it.
It reminds me of like the beginning of like the Eyewitness movies, like the video where like it goes to like the museum, like the different rooms.
But it's a meeting place. It turns on your microphone, hear each other talking, all that stuff. And that's another place, we're gonna see that more and more. Cause, well, look at that Zoom screen in front of you, that's boring. We can meet in the 3D world and actually interact with each other and objects and stuff. That's a much better place for remote interaction for humans. It's much more natural than sitting in front of a black screen with names written on it and a chat room off to the side. That is definitely something that the generic term for who makes that is what we would call game developers, even though it's not a game. We're not going to try to prevent somebody from joining the meeting. They have to jump on 3 turtles and find a secret box before they can get to the meeting. That would make it a game. We want them to come in and stuff, but it's the same skills we're practicing here. So this isn't the only place these skills apply. We do that in 2D as well, right? And it's still way more interesting than that screen for a Zoom call. Run the mics and stuff. There's one link that goes right to the Mozilla one, and then the one I'm hosting myself. I can't share the screen on the one I'm hosting myself. I think I forgot to open a port, and I can't figure out which port I need to open in order to do the share screen. So eventually I'll pick a number somewhere between 1 and 65, or well, really it's between 1,024 and 65 million and something. But there's a number somewhere in that range that if I get the right one, then I'll be able to share screen. I just haven't found where I can look it up, and there's definitely too many numbers to guess. But I think I have the wrong port number. So on the one I'm hosting myself, which does connect to the same room, no matter how you go in there, it all goes to the same room and interacts. So another application of those skills, and as the VR stuff is taking off again, we do have a bunch of headsets here on campus now, so we might try to look at that, and I will let you know before the day we do that, because obviously that'd be a much better day to be on campus when you put the headset on, unless you happen to have your own VR setup. But I was really surprised that it's a full computer system, because I only ever heard gamers talk about it. I thought it was just a console, basically equivalent to a console. It was only for playing games.
I've heard like a lot of people like they even use like the VR headsets with the elderly, and like showing them like pictures of the past, or for that matter, like having it feel like they're going on a trip somewhere to like Ireland or just anywhere.
Yeah, that's the sort of things I thought it was for. At most, instead of a game, it was still, you would be looking at pictures of virtual environments. We can do Word documents and spreadsheets in.
Yeah,
It's like any other computer system. Any other modern computer system we use. That really took me by surprise, because I never heard anybody mention it. People just kept talking about games and games and games, and occasionally things like that. It's like a virtual trip to Ireland, or a virtual tour of a school, so you don't have to commute to the school you want to go to, because a lot of people travel a long way to go to college, right? It costs a lot of money to if you grew up in Indiana, it costs a lot of money to go take a tour of Stanford before actually attending Stanford. So things like that, which it follows suit from the games. I didn't realize the other stuff was in there.
Or like back in COVID time where they had like virtual driving, and like being able to like look at the car in like a 3D model.
And as far as us in here, the only difference from the other game development we'll do is configuration changes. So we just go into a menu and change some configurations, and then our game develops the same way. So it immediately follows from this knowledge, from the development perspective. Which another big convention, and with good reason, video games took very, very quickly to what's known as object-oriented programming. Object-oriented programming, which obviously is an acronym. We get OOP, and it's very common. I follow this commonality to add an S at the end. That way our acronym is nice and pronounceable. Because oops is a lot easier to say than oh, big mouthful. Probably wouldn't have to think too hard to have necessary, right? Like software or systems. So it wouldn't be hard to find something that stands with an S, but the S is just there to make it a word. To make it one of our most common words, so it's really, really easy to say. The very short version of what this is it's customized. And I put customized as the verb form because we're the ones that are going to do it. We don't get something that's custom. We customize it ourselves. So the verb form of custom. Customized data type. That's the very, very short version of it. I'm sharing my screen to show why that's important in game development. So with that example we're just working on, I'll start with the player. So I spelled things out this way on purpose to kind of indicate everything that goes with the player. So our player has the speed he's moving. This is XY coordinates, the image that's related to him, the player bounds. And you might remember later, once the loop starts, we had to keep adjusting those player bounds with the image every time through. So we had to adjust our position and the bounds. But we have lots of data types about that. Same thing with a coin. We have our position. And then we have the image. Then we have that rectangle for the boundary. And went ahead and started that coin somewhere. I think that was just a remnant from before we actually started moving it. But we have lots of different data types for all of our stuff. And on these two, if I went ahead and started let me go ahead and add this line. Player bounds x equals player x. So not a new line. I just left that off the first time because our loop did it on the very first frame of the game. Those instructions are there. I just, for comparison, go ahead and put it in here. There's a lot of things that the player and the coin have in common, right? They both have the XY position. They both have an image. They both have that boundary. And then they need some action to occur so that the boundary moves with that image. They have all that in common. And the only thing unique, well, the player has that unique speed at which it moves. And if I scroll up a little and copy and paste this down below, let me do a couple copy and paste, that way everything's still together and shows on screen. So now they have a lot in common, but they also have different unique details. The player has the speed that it moves at, and the coin has the sound effect that it plays. And lots and lots of different data is involved. So for our player, it looks like we have what, 1, 2, 3 integer data, 3 pieces of integer data. I go away, Bucks. 3 pieces of integer data. Then we have some image data. And then we have some rectangular data. And we need to do stuff with that. So we have lots and lots of different data that is required to define our player object or our coin object. So what object-oriented programming does is we're going to make our own custom data type. So instead of having a whole bunch of separate data, we're going to make one type of data that has all of that. So we combine our existing data types into a new, more complex version, complex sort of data. Something that has all of that stuff built in, but we go ahead and connect it into a single type of data. So that's all we need to define our player. We don't need all those different variables to keep track of. They're all consolidated and into a single thing. There's a couple key concepts. The first one is encapsulation. And you'll notice the word capsule is right in the middle of it. So that's the creating that custom data type. Think of it like a time capsule. At some point back in the past, it was for somebody maybe in 1953, a classroom full of people collected random items that exemplified what it meant to be alive in 1953. They sealed them up in a box and buried it. So the idea of a time capsule. So we could go dig that up today and open it back up and see that exemplification of what it meant to be alive in 1953. Or we could do that for 2022. Although mostly it would just be a computer in our, we would just bury a computer these days. But that capsule includes everything that it means. So all of those different data types we had that went together to define what it meant to be a player in that example, we can make a custom one that's encapsulated and then just have one item that includes everything that it means to be a player in the game or a coin in the game. The second object is inheritance. And we don't have to start at the beginning every time. Like I pointed out, there was a lot they had in common. Right? Both the coin and the player have XY coordinates, an image, and a boundary. So we could make a parent class that's just stuff, the items for our game, that has those basic components that everything's going to have: a position, an image, and a boundary. And then we can create child classes from that parent custom type of data that inherit all of that and add more details to it. So one would, like a player object would inherit from that parent that has all the stuff it would have both coins and players have in common, and add the speed detail. And then it becomes a player because we have the speed at which it moves. Whereas another child class would take all of that generic stuff that it inherits from the parent and add details for the sound effect, add that sound effect detail, so that we can do that. And we enclose everything. And inheritance is a lot like we use it in our society, right? People go out, they spend their entire working career building up something, right? Hopefully building up something, some savings, buy a home, some land, all that. And when they eventually grow old and pass away, their children inherit that. They don't start from zero. They start with what they get from their parents and add to it. So same thing, we start as generalized as we can, and then we'll make a class that inherits all that general stuff and adds more details. And we can keep adding layers and layers and layers. And because of American culture and the way we use inheritance normally and the way it applies in object-oriented programming, you think of it like generations. Each generation of a class inherits what the family had before and adds a few more details to it and builds up the perfect type of data to define what we're trying to do with only, I guess you can think of it, define all of that stuff in a way that we can stick it in one variable. We don't need 10 different variables to hold all those values. We'll put them up, we'll define our own custom type of data, and then we'll do one variable that holds that custom type of data. And we can access the stuff inside it through it, which we've already been doing a lot of. That's what all the dots are.
So it's kind of like,
Yeah, so there's like a Pygame object, and one of the details worked in there is dot initialize, dot in it. So we can say that as a variable. First one I say this, or like scene. So that pie game, there's a display object that has everything it means to be a display in pie game. So we took all of that stuff and instead of lots and lots of different variables, the height, the width, the title that shows on it, which we didn't do. We didn't do this example. We might want to change the little words and the icon that shows up in the corner. For some reason with pie game, people really like the turtle. People very, very rarely change from the turtle icon if they made their game in pie game. That's been going on for decades now. But yeah, even though people surely drew their own icon, they just tend to not change it from the There's a tendency to not change it from the little pie game turtle. But the display is an object in all the different data types. So instead of all these different variables we have to keep track of, we make our own type of data and store it in one variable, and it's a lot easier to keep track of. There's a picture I like to draw in classes where we get into it in depth. It's not on our core learning objectives. It's just, it goes so well with video game programming that we tend to always use it. It fits very, very nicely. Because then we can think of it like game pieces. We have that player piece for the game. And we don't have 20 different variables trying to track all the different types of data related to that player. We have one thing. It makes it easy to visualize it. In short, we get to think like a human again. We categorize things like a human. So in a lot of the software development classes where we spend time on it, several of y'all are in the SDEV 140 class. It's not this evening's lecture. And then again, when you get to the 200 class, I always start, I draw a picture, and the picture I draw on the board to start with is the categorization from biology, standard tree of life, because object-oriented programming, when we start diagramming that, looks exactly like the way we draw that tree of life for biology class. So we get to think like a human as far as organizing our code. Inside of that, we still have to do the whole computing logic sort of stuff, but there's a big organization thing. And overall, it's less efficient for a computer, but much, much better for a machine. I'm just going to make up a couple numbers here because obviously it's situational. But let's say because of how much better object-oriented programming is for a computer, or sorry, for the programmer, we can do 1,000 times more stuff easily. So plus 1,000, but it's less efficient for the machine. So maybe to do that 1,000 times more stuff, we're losing 10% efficiency. So minus 10% of that 1,000 things we do. Minus 10% of 1,000 is 100, right? 10% of 1,000 is 100. So we're gaining plus 1,000, but losing 100. So we're still way ahead. It's way advantageous to do what's good for the human. And it's just a little bit extra work on the machine, and the machine will never complain. Machines don't mind if we give them extra work. Or they'll at least never complain about the extra work. So the human can do a lot more with object-oriented programming. And it works really, really well in game development because instead of all those different variables we have to keep track of, we consolidate it. We put all of them into a capsule that defines what it means to be the player in the game, or the coin in our example here, or the mob or the NPC or whatever we're defining. It's all consolidated and encapsulated. And our third key concept, I'll write the word out here, is a really big word for a really simple concept. Polymorphism. Many shapes, if we go from the origin of that word. Many shapes make more sense than using the Greek origin. But polymorphism is a really big word for a simple concept. The example I like to use is hammers. I'm going to draw a hammer on So everybody's seen a hammer before, right? It's a combination of two levers so that we can redirect forces. And usually push with this side and pull with this side. And typically if we're thinking about a hammer, it's gonna happen fast enough, we'd say hit and fry. But we can push and pull things slowly with a hammer too. We can also hit stuff with that side, that's with the claw side. Sometimes that's what we need to do. That's the first step of it, but I think most people know what to do with a hammer, what that tool is designed to do. That combination of levers designed to like drive in nails, or if a lot of force is needed to put something in the right spot, put a peg into a hole or something. That's what the tool is designed for. But that's certainly not the only thing we can use a hammer for. A hammer is really, really good for like keeping blueprints from blowing away on a windy day on a construction site, right? It's a nice heavy object, it's gonna hold the blueprints right in place. So that's a different use for the same tool. It's not what it was designed for, but it works great for it. On a construction site, a hammer will also work great as a doorstop. It's a nice heavy object, so if you're gonna carry materials in and out on the construction site, you probably want to prop the door open because it's kind of hard to open the door when your hands are full of heavy construction materials. Hammer works great as a doorstop, but that's not what the tool was made for. That's what polymorphism is. It's the ability of a tool to act in a manner other than what it was designed for. Many shapes, if we go with what the Greek origin words mean there. So a great big word for a simple concept. There's a lot of stuff with inheritance. As far as like coding, one example might be if we had some statistics program. We were making objects. One of those objects is probably going to be to find the average. And there's a couple steps to finding an average, right? We add everything together, count how many there are, and then divide that sum by the number of things we had. Well, one of those steps was adding everything together. So if that tool for finding averages was well constructed, then we should be able to use that part anytime we need to add numbers together. That's we would probably never do that because we have the plus sign on our keyboard. But the tool designed to find averages would also work just to find sums, because that's a step along the way to find averages. So there's more than one use for that thing. The main thing we want is the encapsulation and inheritance to keep things organized. So like with our objects here, I just want to quickly look at the syntax of it and then make sure there's plenty of time to do stuff, because that's I kind of want you all to take the example here and run with it and see if you can turn that into object oriented. So like download this code from GitHub when I upload it here in a minute, and then directly turn that into. So first thing I'm going to do, make sure it's saved. I didn't make any typos, still working like it did. Yeah. First thing I'm going to do is, like always, it's a good idea to work with a copy, so you can always get back to the previous example. I'm going to close that and go in here. And this one really should have been called step 2. So I'm going to rename this before I make a copy. Rename this as step 2. And then I'll make a copy of that to work with. Control copy, paste. Oh, rename it. Three, and then I'll rename this file as step 3, which is going to be to turn it into object-oriented programming. And that's not even just a good idea. That's not even a programming thing. If you're writing an essay, it's still a good idea to work on a copy. Once you get a paragraph that you're really, really happy with, you should probably try to avoid accidentally messing up that paragraph. Work on copies, or keep it around, somehow keep it around so you can get back to it along the way. I'll start with the player object and go over the syntax. So there's different ways to do this. And the optimal way relates back to something in computers that you probably haven't sat down and thought about directly. Remember going over all those ones and zeros, how machines work with binary states? Think about 1 and 0. A computer either does something small or it does nothing. And that's the two things a machine can do. So lots of small things are better than one big thing. And a lot of times people try to put as much as they try to put everything in one text file. And it is better to put your code in lots of small text files instead of one drive. You can't use them separately. Like we kept importing things from a folder called pipe from I'll refer to it as this file called Pygame. But we want to use those pieces separately. And if we put them all together in the same file as the first step of that, if we put them all together, then we can't, we might run into trouble separating. So it's always a good idea, always a better idea to define your objects in a different place than you're going to use them. And a quick keyword here is an object is the one we actually use. You can think of it like a noun, the thing we hold. When we put it together in our code, we just design it. And then we'll fill in details later. Like we say we have a spot for a color in our design. And then when we actually go to use it in our code, that's when we say we have a color and fill in that spot we set to store a color. Like for our background box where we drew that. So it's always a better idea to define the stuff in its own file, and the design is called a class. It's like a blueprint. You can think of a subdivision. Typical American subdivision, 25 acres of 2-bedroom ranch homes with a garage and a basement. Typical subdivision, I guess Whittier, anybody's ever been to LA, 140 square miles of 2-bedroom ranch homes. The city where they filmed Wonder Years at goes on and on and on and on, and nothing but 2-bedroom ranch homes with a garage and a basement. All of the houses are built from the same blueprint, the same design, but they're all unique, right? Some of them have the garage on the left, some on the right, some have a full basement, some have a half basement. Some of them have circles in the door, and some of them have triangle windows in the door. Everything, some of them have a porch that stretches all the way across, and some of them might have a porch that only stretches halfway across. So they're all built from the same design, but when they build them, they change up the details. Object-oriented programming is a lot like that. So we have to set up our design, and for in object-oriented programming, that's a class. I guess one more background thing before we get started typing. This was invented back in the 1960s. A guy in Norway. I'm not even going to make an attempt to pronounce his name. I think I tried to write it in one set of lecture notes, which over in the folder, the yellow page, which I haven't pulled out yet today. I tried to write it down once, but I'm not even going to make an attempt to pronounce a Norwegian name. I'm sure you all have seen those spelled out before. And Norway is a very, very rich country. They had probably the nicest computer in the world in 1962, and his idea worked great on that best computer in the world. But the typical computer couldn't handle it until about the mid-1980s, around 1984, 1985. The average computer could handle the extra stuff that comes with it because it's good for the human, and whenever something's good for the human, it's bad for the machine. The better it gets for the human, the worse it gets for the machine. The harder it gets for the human, the better it is for the machine. There is a direct correlation, correspondence, and all of those words. They are tied together. So, in 1984, 1985, the average computer could handle object-oriented programming, not just the best ones in the world. And programmers started using it, and we've never looked back. We don't even. As far as functional programming, we can treat Python functionally. But really functional programming languages are something, the history books, it's in the history section of your textbooks. It's not something we even acknowledge exists anymore. As far as functional, we acknowledge it exists, but we don't use it. We only use object-oriented programming stuff. Python allows us to treat an object-oriented language as if it was procedural, but what it actually is it's static objects. Python automatically creates static objects. Several of y'all know what that word is. And for those who have me in a 200, give me a 200 level class someday, you will hear me go on and on and on about that word, because it's a very, very, very important word. So Python automatically creates a static class. So those of y'all who have heard me go on and on and on about it, you know that if we have a static, if it's static, we can just jump right in and start doing stuff. We don't need to instantiate objects. So that allows us to introduce programming concepts without using a functional language. So Fortran and other things that you might hear history, Fortran and COBOL are like mentioned in a history book. We don't even use them anymore. So once computers can handle it, we pretty much everything's object oriented and we haven't looked back since. So you will see quite a bit about it since. So to make our design, we use the keyword class, and then we give it a name. I'm going to start with stuff. It might be different names, but this is the parent. This is what everything has in common. And then we have to define some sort of, we call them constructors, the thing we'll actually call in order to build this. And in Python, it always looks the same. So we're going to define a function or a method, and you've probably always heard those words used together. We use them interchangeably when we talk, but there is a technical difference. In object-oriented programming, we only have methods. Functional programming only occurs in procedural or functional programming. But we use the words interchangeably. We're going to define a method, which, speaking English and getting away from that technicality, which keep that in mind when you have to take multiple choice quizzes and things like that. Define a function or a method, whichever one fits better in the sentence, really. And in Python, it always looks like init, and the first parameter is going to be this special one called self. What that's doing, I can point that over here. Like here we created a display object so that we could draw stuff on our screen. Then we put it in that variable called scene. So at that point, scene is the self. Scene is the version of that display class that we're going to create a particular one of and actually use something from that design. So we always have to, and the Python interpreter will pass in that parameter, so it always has to be first. And then the things we need. So no matter what it is in our game, we know it needs a position and an image and probably some bounds. I guess we could go ahead and put that on everything. That's a choice, right? Some stuff's purely background, might not need bounds on it. Well, I'll do bounds afterwards. So I'll do the background would have coordinates as well, right? The background's at 0, 0. Just to tie that together, kind of see that. So we always have an image and XY coordinates. So that's our top level. Well, there's a top level that comes from a language. Python, when they made that, they made a class called object that has certain things that we'll need that they thought everybody would need for no matter what they were doing. So we all automatically inherit from that. So we'll start without inheritance. So the keyword class, whoops, then we give it a name and the parentheses are empty at this point. And then Python syntax, which I believe everybody has seen before. If you're more familiar with C family, after the header, we put in curly braces to define a block of code that goes together. And in Python, they thought it was more natural for humans to use line breaks. So we use a colon and indent to define a block, take the place of the curly braces in C family. And the first thing we're gonna do is define this little constructor for when we make a new one. And that new one's gonna need an X and a Y coordinate and an image. Because everything in our game, all the stuff we need to make our game is gonna have at least that. And then afterwards, there'll be different details. And then we need to connect these parameters. When it's asked for in the code, we're going to send arguments to fill these parameters we're creating, but we need to make sure they're directly connected to that self parameter that the Python interpreter knows about. So it's fairly conventional to use the same one. It's not required, but those two X's only look the same to us. When it gets translated into a machine language, the computer would never even come close to getting them confused. They only look the same in the text file. So it's conventional to use them the same one as long as one of them is tied to that self object. So self.x is that X that was passed in. And self.y is that Y value that was passed in. So there's our coordinates. There's our position. And self.image, this is probably going to be a file name, right? Pygame.image.load, whoops. Pygame.image.load, then the image we want to load. For the background, pygame.image.load, the image we want to load. Pygame.image.load, then the image we want to load. So that part's always the same. The only thing changing is that file name. So that's probably what we want to pass in, just that file name. Then that part that's always the same, which I can copy from right here, or any number of places over here. When we load connected to the self image, we'll call that Pygame method. So that the file name gets passed in, and then we go ahead and run that through there. So now the thing connected to the object itself is the sprite to show on our thing. Oh, actually, that would probably be a better name. So change that up to a better name. So an X position, a Y position, and a sprite. So maybe instead of image, I can say image file. So we'll pass in an image file. That way our predictive text tells us we need an image file for this parameter to fill this parameter. So we pass in the file name, and then pygame.image.load turns that into a sprite, which is actually a synonym for image, but we would probably think a sprite is the one we're actually going to use in our game, not the image file. We'll talk about sprite sheets and where that comes from. But now we're doing Pygame stuff here, so we need to import that library. So import the Pygame library. Remove that out of there, and then I'm going to save this as, I'm just going to call it objects.py. So I pointed out that it's better to put them all in different files, and then we can import them, but for the sake of the example, I'm going to put them all in one file for the sake of clarity in the example. We're not doing anything big enough that we would need to worry about the nanoseconds that would save. Nanoseconds do add up though, right? Or actually we're in Python, so it's probably milliseconds. We're saving a few milliseconds, but we're doing it 60 times a second. So, or if, yeah, we're not saving, let's say 10 milliseconds. We do that 60 times a second, how much is that? So we have that extra 10 milliseconds, 60 times a second, and we've already wasted 600 milliseconds. How long does that get? How much does it, how many seconds does it need before that delay becomes noticeable? And from saving a few milliseconds when we write our file. But for the sake of, we're nowhere near that in our example here, so for the sake of clarity in the example, I'm gonna put it all in one file. So now we have that stuff. Probably want to show it on the screen. We have an image. That's what we did with all our images, right? First thing we did was we showed all of them. We came down here and blitted the background sprite. And then we blitted the player sprite. Blit is probably a word you never saw before we talked about Pygame last week, right? So let's give this a name that we would use. So show, that sounds good. We're gonna show, we'll define a method called show. And then once again, the first parameter needs to be itself. So actually, when we ask for this method, we will say show and then empty parentheses to look like we're not passing anything in. Because that self one will already be filled. That's automatic. The interpreter is going to do that. And then we'll do the same thing we did when we showed our image. I'll just copy this one here. For those who haven't had me in class before, I always make a big deal out of keyboard shortcuts. If you're not familiar with the home and end keys on your keyboard, you will want to get familiar with those. Those are always in a different place. Like end goes to the end of the line, home goes to the beginning. We often have to copy and paste like a whole line at a time. So having a nice way to highlight that all at once is useful. And before everything had a mouse, and even since then, because we didn't delete it, if we wanted to highlight stuff, we used the shift key. It's like if you hold shift and then move the arrow keys around, that's how you highlight stuff without the mouse, if you hadn't seen that before. So if you need to copy and paste the whole line, a really quick way is to put your cursor anywhere on there, and then always push end first to go to the end of the line. Page up and page down are useful there as well, but from the end of the line, if you hold shift and push home, it'll select to the beginning of the line. And in pretty much every text editor, if you push home again, it toggles back and forth between the indent. So that's why I always do end first. And then home, whether you want to go include that indent or just right where the word starts. So put your cursor anywhere in the line, end, hold shift and push home, and then that'll highlight that line really, really quickly. So paste this in here, and we need to change this stuff. So what we're gonna do is we're gonna split this. Oh, we probably need to know which scene we're drawing stuff on. So that'll be a parameter. We could either include it in our constructor or just in this method. I'm going to put it right in this method. So maybe this stuff can be shown in lots of different scenes. We can use it in different games. It's not particularly held to that same one, but we could just as well have put that up here. What game are we using? So I'm just going to, instead of calling it scene here, just for clarity, I'm going to switch it back to display because that's what Pygame calls it. We need a display sort of data, and that will hopefully help make sense of it. Then I'll copy it, just modify this one that already worked. Instead of player sprite, we now have self, so the object we're working with, as a dot sprite as part of it. One of those things encapsulated inside of it is a sprite. So to access all that stuff we shoved in our capsule, we use the dot operator in Python. That varies language to language. So that's sprite. Anybody that's seen C++ knows there's better ones. Pointers are usually better than dots. We can use both. We use both in some languages. Some languages we restrict it to just one. In Python, we only have the dot operator. Having multiple ways is a bit confusing. Those who work with C++ also know that. Having pointers and references often gets confusing as far as which one we need and which order they have to go in if we're going to mix and match them. So a lot of times we'll just, most of our other languages just chose one and then got rid of the rest of them. So same logic, it's just already encapsulated in this self thing we're working on, we're designing. Same thing with X and Y. So instead of those variables that we used earlier that only held an integer, we have some stuff included in our capsule, encapsulated in our object that we'll use. So self.x instead of player y is self.y. So hopefully at this point you can see we're not really changing the logic of what we did. There's enough to create some stuff and put it on the screen. Which I guess the only one that's going to work for is our background object, right? So let's go give that a test. General rule in programming is run a test every chance you can. So I'm come up here, and instead of doing this, loading this image in, I'm going to instantiate that one of those, instantiate an object from that class we just designed. The stuff class, because the background doesn't need to be anything other than just stuff for the game. That most general level. Coin and player probably aren't going to be stuff. We can do better for those. But the background is just some stuff. So I'm just going to make this one thing called background. And that's going to be some new stuff data. So I'll call stuff. And then we need some things in the same order. In particular, we need an X, a Y, and an image file. But that's over in this objects.py script, which is kind of what we did here. The code we need is written somewhere else, so we have to import it. So to get it to show up on predictive text, I'm going to come up here and import it. If we're in the same folder, it's no problem. We can just grab stuff from the same folder. Make sure you put an S on there because object wasn't the best option, I suppose. So if we say import objects, then that's going to import that other file. So then when we create it, we can say objects.stuff. And then it's on the predictive text. I was getting ready to change this. I was going to put the dot stuff here. We could just import it from there, but we would need to do that for all of our classes. So I'll just stick with what I did earlier. It also makes it clear where that's coming from as well. So now let me erase this line and type it again for the purposes of example. Whoops. And try to do so without bumping the little touchpad. So objects dot, and now notice that at least in Spider, the predictive text draws to that. If you're typing someplace else, you might not have adaptive predictive text, but Spider does. So it's predicting, okay, the only thing in there is stuff. So if we select that, then the predictive text or those pre-filled in things tell us what to do. So for our background, that's going to be a 0, 0. Because all we need to know is that top corner in our background file image was specifically chosen to fill up the whole space. And we'll talk about sizing before long. Some of y'all may have seen it before. The classic numbers, which are actually a little outdated now because we don't make screens come in every aspect ratio. At one time, all of our screens came with pretty much the same aspect ratio, but they don't anymore. It was so nice because we knew, we didn't know the exact size of everybody's screen, but we knew that ratio the rectangle would be. But nowadays, screens come in just like every conceivable size. So
back when times were simpler, it was just simply 720 by 480.
Yes, or and even multiple of those numbers. Yes, 720 by 480, you'll probably see it in reference material. That was the cathode ray. That was the perfect ratio for electrons to be bounced to different sizes. So the early days of the flat screens like we have today, they stuck with that ratio, but they drifted away from it.
Yeah, because I mean, that's what we use, like just as
Not even flat anymore.
just general, because it's like, you go bigger than that and go down, it's gonna shrink down.
Yeah,
But it's like if it's real small and you blow it up to that point, then it's gonna expand.
Yeah.
Expands the pixels everywhere.
yeah. We'll look at that causing an error soon. I do have a screen that still has that ratio, so I'll share that and run the same game on there at some point. So we looked at that other file that we imported, and then that dot, like we've seen the dot over and over and over again in Python. You may just not have encountered what it's doing it. It has something in that file is stuff. And in order to create this stuff object, we need an X, a Y, and an image file. So now, instead of flipping just that picture by itself, should be able to call that background object and then dot show. And then the show method just needs to know what display is it showing on, which is called, that's what's called scene here. Hopefully that's not too confusing for object-oriented programming. It does take some getting used to. It's different and it's easier for the human to work with, but you'll have to, like coding, it's a different style of coding, so you'll have to practice around with it. Though game development took very, very nicely to this, and I looked and looked and looked and looked and could not find a Pygame tutorial that did not use object-oriented programming. Like after 1985, when our computers could handle it, we pretty much never looked back, especially game developers. So I want to make sure and cover that because only SDEV 120 is the prerequisite for this. So now we can make some child objects, and then that's the most basic, most basic data that it requires to feed something in our game. So we made a more complex data type. So now we have that most basic data type something has to be in order to fit in our game. It has to be stuff. We also have class, I'll go with prop for making the coin. The coin's like a prop, or maybe the player first, which is a character. And this time we want to inherit everything it means to be stuff. Character is a child of stuff, right? So we'll get all of that X, Y in the image, and then we need to extend it, add more stuff. So we'll have self, and this is going to look funny if you haven't seen this in your Python code. So we need a new parameter to put in here. How? Characters move. That's the difference between characters and other, between our character and our background stuff. The character is going to move around. So the character will have a speed that it needs. And then all the same stuff as the parent object. So to write all that stuff, instead of writing it twice, I'm going to write asterisks, args, and 2 asterisks and quarks. And the symbols there, args and quarks, that's what he used from the very first version of Python that he started creating on Christmas holiday of 1989. So we just didn't stick with those. Those are just reference values. Like anytime we set up a variable or a parameter, we can call that whatever we want, but args and quarks.
Does all that stuff not have to be in an init?
Oh,
Under it?
You are correct. I'm typing in the wrong spot. Let me cut that. Sorry, I'm getting ahead of myself. Thank you, Ron. And in that stuff goes in the init. And what goes in these parentheses is the parent. So we want to inherit from stuff. Sorry, I got ahead of myself. So defining a new class, it's gonna be a character, and it inherits everything it needs to be stuck in the game. And then in our constructor, we'll need one more parameter. We need a speed value. And then args are the single value things. So anything that has only one value to it will, from the parent, the Python interpreter will figure out any of these that have a single value. So all three of those, integers and then a file name, which is a string. All three of those will get passed into args. And keyword arguments is for lists, tuples, dictionaries, collections of things. So whatever gets, so we have this, and then we have a bunch of either single value items or collections of things. So it's really the asterisk there that's important. And then to get those to the up to the parent, we can say self dot super. Or is it just super? Oh, sorry. Super, I was thinking of the wrong language for a second. There are definitely some downsides to knowing lots and lots of languages that blend together after a while. So different terminology instead of parent and child, we can say superclass and subclass. So subclass inherits from a superclass. And that's the keyword we need here. So the superclass and dot, and we can directly access that init method in the parent. So we have to pass everything up. Whoops. Let me hit undo. Go ahead and go on line. So we want to pass the reference to ourself up to the parent. And then that args and quargs will get passed up to the parent. And then we can add to that. So like self.speed is going to be the speed parameter that was passed in. And we inherit from the parent. So we have a show method already. We don't have to write another show method. We'll see that here in just a second, be able to use that. Speed would have to do with moving. I think for moving, we'll pass in some sort of value. I'll write a quick version so we can finish up here. Define move. All right. Horizontal and I'll do two methods. Well, actually, I can do it as one. Move. And then pass in our X and Y values that we want to move. So that if we're only moving horizontally, we'll pass in a 0 for Y. So then we only change the X value. If we want to move only vertically, we'll pass in a 0 for X so that we only change that Y value. That's probably a nice, good way to do that. So we should be able to call self.x at this point equals whatever was there, self.x plus a little bit more. Oh, I forgot self. Again, that self parameter always has to be first. So that's one way to write it. And some of y'all, I wrote that one first so y'all can run with that. Let me clear that up and describe that that's the same thing. For those who are a little bit newer to this, what you probably want to do instead of this fancy stuff here, is just copy what you had up here. XY image file. And then just pass it in this way. And then we can copy all of this stuff. So for the variables, just copy and paste them. And then know that you get the methods. Does that look a little bit clearer?
Yeah, this actually works a lot better than the first one, because it's like this one, it's like it's easier to see what variables are with what, and you don't have all the extra fluff in writing.
Yeah, that's a common one. That's a common one to start. We end up with a lot of redundancies. Because when we do it this way, we actually have two X fields. But the computer will notice that one of them is empty and one of them is filled. So the other way is the better way to do it, but it's a little more confusing starting out. But some of y'all who have had a bunch more advanced Python. I know you had a bunch more advanced Python. We talked about all kinds of stuff last spring. We had 16 weeks to dive into fancy stuff. We got all the way to parallel processing, didn't we?
I think so. I can barely remember it.
There was a lot, but yeah, we looked at a whole lot of Python last spring. But this way, yeah, you'll probably want to do it this way. So same talking applies. So we kind of matched our order. And copied those down, so it's a child, we're taking it the same way, and then we add to the end. That's a little bit easier to follow when you're starting out, but for those who have had higher level had more programming, the other way would make more sense, especially those who have actually studied C++ formally. That asterisk and that args and quargs thing, I didn't even really have to tell you what that was for. Like, oh, it's a pointer. And it's a pointer and a pointer. So people who have studied C++ know exactly what that was. But this looks a little bit, it's easier to follow and just recreate your variables, which creates a redundancy and not a very efficient way to do it, but it's easier to make sense of it first. And then just know that we inherit all of our other methods. So we still have a show method, which, yeah, that's probably a start. There's more we could do, but I'll go replace some of the player object with that. So we'll have a speed, an X and Y coordinates, and an image. So we don't need any of those. I guess it'll probably 20 minutes to 4. Yeah, I think we'll be able to add the bounds in there as well, and then you can extend it for the coin. Try extending it for the coin for some basic practice added during our time that's still blocked off, but after the lecture portion is going to finish. So instead of all of those separate data types, let's just make one variable to store some player data. Or in particular, we'll call it player, but what it is it's going to be character data. So again, we're going to look at that objects file we imported, and then dot. And there are a couple things we can grab from it. We can either grab character or stuff. So we grab character. Once again, we see what it pops up, what needs to be there. So X, I'll just type in those numbers that we used earlier, start at 1.3, 1.3. And I'll grab this file, so copy and paste. Copy and paste as much as possible. Humans never make typos, or sorry, computers never make typos. Humans always make typos. I can't even say that sentence correctly. Making typos is a human trait. So copy and paste as much as possible. And I set the speed to 3. So now all of our data is consolidated, is encapsulated, sealed up into this one variable instead of a whole bunch of different ones to keep track of. Which for the time, until I get to the next step, I'm going to have to highlight that and hit Control-1 or Control/ or whatever the shortcut is to comment out those other lines. Because until we move those into our object, they're going to cause a problem now. But I wanted to go ahead and draw that on here. So instead of all this, whoops. I'll just start here at the top. Go ahead and leave that there, so that way the things are marked. So here's where we were moving. So if we push the A key, instead of subtracting from that field, that way I tried to generalize it, isn't gonna work. Let me rewrite this. Yeah, I'm gonna rewrite two of them. I'm gonna write move horizontal and move vertical. So self.x is changes by whatever self.x was plus self.speed. Sorry, I got a little distracted. Let's take a step backwards. I'm getting too anxious, I think, and trying to jump the gun. So this will work a lot better. So let's just move horizontal to begin with. Move horizontal and vertically separate. So if we call move horizontal, we just increment our spot. And lines like this are one of the most common things we do when programming, right? We have this variable and we're gonna change the value based on what was already in that variable plus something else. So pretty much all of our programming languages also have an abbreviation for that step right there. So if we said self.x plus equals self.speed, that is just an abbreviation for that line above, because it's so common. They're called assignment operators. I usually like to phrase it as reassignment operators, because we can't start off with that. But if there's already something there, we can reassign the value. And then we can do a default vertical one as well. That'll be and for vertical, same thing, but we want to change our Y. And I'm going to add an optional parameter in here. That's what I thought for a second about and decided this will be better. Because what about so plus for X, we'll move to the right, start left, move right. Plus for Y, starts at the top and moves down. What if we want to move back up? So I'm going to add an extra parameter here that we can use for true and false. And I'll say up equals false. Oops. It's Python, so capital F. Up. Right equals false. And up equals false. So by default, we're going to move left and right, or we're going to move right and down. And if we want to move, say, to the right, we just pass in true. But we can also leave that blank because there's a default value. We don't have to change it. I'm trying to fit as much as I can in this example. So then we can just check that. So if, I also say right, a lot of people at first might want to put right equals true or right equals false. But the Boolean right has a true or false value, so we don't have to do that comparison. So if right is holding the value true, then we want to decrease by the speed. But if right is holding the value false, then we want to increment, then we want to increase by our speed. And some of y'all might be new to programming and need a little bit more practice, but does the logic there make sense? instead of a fancy condition, we're just passing a true or false. So then we can just check that directly. Is it? When planning, replace the word if with the word is, because we're asking the question. But when coding, we're not asking the computer, we're telling the computer. So if right is holding the value true, we'll decrease our x coordinate. Else, which means right would be holding the value false, or the default value here, will increase our x coordinate. And if up, so same thing. Up is a negative y, so self dot y decreases by our speed. Otherwise, will increase by our speed. I'll let you look at that for a second. Does the basic logic make sense? And then obviously in most games, it's going to be more complicated than that. For our class example, since we're talking about time, I'm trying to look at those basic minimum starting points. So that with a whole bunch more details in it to fill out a game. Then you just start adding games. So that gets us movement. And when you're making classes, especially at first, you're probably going to do stuff like this. You'll start making it, and then you'll go over here and try to implement that. So save that, come over here, and you'll start implementing it, and then you'll hit a spot, and it's like, oh wait, what I have there is not going to work. So go back and make those adjustments. So there's back and forth and refine it. And after you've had a lot of practice with that, then you'll be able to just make your class from scratch to begin with and jump over to the other one. But at first, be prepared to jump back and forth like we just did there. So now instead of changing that variable, which doesn't even exist anymore, our player data as a move object. So I'll get rid of that earlier line, and A should be to the right, move our character to the right, and that's what our boolean is. Let's pull it up on the predictive text. Player dot move horizontal. Oh, we didn't fill it in. There's a default value, so it doesn't. We don't have to pass that parameter in unless we need it. So I'm going to change that to say true. And then I'll just copy and paste that for all of our movements. A, B is our other horizontal one. Paste that in, and here we want to move left, which is our default value. So we can just leave that blank, or we could actually pass in false, because some people like consistency can be good. But there's a value already there, so we'll go with that. Instead of, with the W key, instead of decreasing that variable, we'll call our player data and move vertical. And W is up, so that's when we need to pass in true. And same thing, if we push the S key, our player data, we want to adjust that data to represent a vertical movement in the downward direction, which is the default of false, so we can just leave that blank. And the choosing to make that, choosing those names and the value for false was completely arbitrary. Whatever word makes the most sense there in your mind, you can do stuff like that. So there's that. I have to comment out this part for a moment because we haven't done we haven't put bounds in our object yet. That'll be like step 2 after the first test run. Oh, but here we go. We can comment out the bounds so it doesn't throw an error. And then just like we did for the background, instead of scene.blitz, I'm going to replace, comment that out, always comment, then make the changes, and then delete the commented out part. You never want to just delete immediately, because if your new stuff doesn't work, you want to be able to get back to the last thing that worked.
So it's kind of like Photoshop's version of hiding layers.
Yes, hide the previous layer, And then make a new layer to work on and only get rid of that hidden layer when you know for certain you don't need it anymore. So our player data, since it's a child of the stuff data to make up our game, it inherited that show method. So we can call it from here, even though we didn't write a show method in there. And then once again, what scene do we need to display that on? I don't see any little X's marked, so run that. You can see all those previous variables about the player, there's no bounds, are marked out, but if I push over, still moving the same up and down. Unlike the background, the player would probably have an animation method, right, run through our frames, because that's part of the player data specifically, not a separate thing. So everything that belongs to that player, everything that it means to be, you can think of it like a game piece, like little plastic pieces on Monopoly, or metal pieces on Monopoly, I guess. Everything it means through that is included in that game piece. And then you move that game piece around as a united whole instead of a whole bunch of separate variables. Game development is very, very useful for making sense of object-oriented programming. But you can see it still works the same. Right now is when I want it to be finished by at the latest, but I could add the bounds in there. Do y'all want me to move the bounds in there, or do you see what to do for those? I see some go ahead and do it here in the classroom. So let's move those over. So we need the rectangle from our sprite. We already have that in our data. Then that's going to make its own little rectangle object. And that rectangle object has the X and the Y. So once we create it, it's going to be there. So under character, we'll have some bounds. Self.bounds is going to be Pygame. Well, the same thing we did here. Oh, actually, it's not even Pygame. We called it right from the sprite, because we already called Pygame to load in the sprite, and then we can call stuff from that sprite. So since we have our sprite, we can say self.sprite and then .get rec. Wrong language, don't need a semicolon here. So now we have our bounds, and whenever we move, just like we saw earlier, we want to be able to those move with us. So self.bounds.x, again, is going to be self.x. And once again, copy and paste as much as possible. So I'll just copy that down to the other one. Which actually, probably could have put that after the if block altogether. So no matter which branch of the if block it takes, it's that same line. So it could have just done self.bounds.y equals self.y. Either one, those two are going to work exactly the same, even though they're written differently. Does everybody see why? I see head nods in the classroom. Hopefully head nods on the Zoom call as well. And then there was one other thing we did with the boundary. Right? Sometimes we need to see it. So let's add another method, define show bounds. Which again is going to be the self. And all we're doing is displaying it or not displaying it, which does require the display we want to show it on. Because earlier, in order to show those, I think it's commented out here now. Now that our players has bounds, we can uncomment that. Oh, there it is. That's what we did to show those bounds. So since our player has a rectangular bounds, we can just copy that one that we know worked from earlier over. Scene display. Might want a unique color that we can access, right? So I'm gonna change that. So I'm gonna put Control X, so it's still on the clipboard. I'm gonna write self.color. And then I'll make that another property for our object. Self.color is that thing I just copied off. Or we'll pass it in. Color. Then in our constructor, we'll take in a color spot. Over in the other file and create that. I'll put the color here. I'll paste that there. Because that way we can have lots of characters with different colors and change the color of the bounds for each one and maybe put it in front of our image instead of behind it. That way we can see it. We can see it if needed. Actually, it'll depend on when we call that show method. But I also stretched that out and made a point out of jumping around a lot there. Okay. You're used to the English language where you work left to right, top to bottom. But now we're in the Python programming language. And that line I wrote a moment ago, x equals x plus 3 or something. The fact that this works shows us that the computer runs this code right to left, not left to right. Because it's going to take the value that was there, add something to it, and then do the assignment. So the computer is not even following the left to right thing. And in the end, it needs to be in a certain order for the computer to work with it. But that order, as far as left to right, top to bottom, is probably not the order we think of it in. It's a lot more productive to bounce around and put the code together in the order you think about it in, and just make sure it's in the right order for the computer at the end. I kind of stretched that out for that point there, because things are spread against. When I realized that needed to be there, the stuff was spread amongst 2 different files. So now we have a color. And player bounds is now self.bounds. Now we have a way to show that boundary around it. And the boundary is also necessary for the collision. So that'll be another change here. So instead of player bounds, it was player dot bounds, or whatever name you give it. And we can change some names, we can change, some we can't. That's a good thing for getting practice is change the ones you think you can. It'll help you narrow down when you hit those keywords that you can't change, because that'll show up very, very quickly. But we still have all the same things happen in the same order. It's just we encapsulated it. We changed how we access it. Instead of lots of different variables each one holding a single piece of data, we put them all together into our new customized data type that has all of those, and then we only need one variable to access all of them. So now it should work the same. Unmute it. Seems like it's still working the same. That background noise wouldn't sound as odd if there was like some music playing the whole way. So that's something I would suggest to see if you can add some to that. So let me clean this up. Okay, so that new stuff works. So let's get rid of the things that we don't need. That happens automatically. We don't need that, so we can do player.showBounds just to have that on there and run a test up. I apparently forgot something. Oh, I have to say where to show those bounds. Did that crash yet? Oh, actually, in Spider, if it locks up, you can just close the tab. close the tab in the IPython console, and that will close any GUIs that you launch from that particular console and start a new console. So if it gets stuck in an infinite loop or something, just or if the thing crashes, just close that. I forgot, show bounds does have to say where to show them at, to show them on the scene. Oh, it looks like it's still stuck at 0, 0. Well, that's better, but it didn't go there right off the bat. So a little bug we probably wouldn't even have noticed, because after we move around, they did eventually get to the right spot. But we probably want to make sure they start in the right spot. So after we create them, we do self.bounds equals self.x. Oh, dot x. The same thing we were typing earlier. Those bounds have an x coordinate. So we can just set it to the same as our image coordinate. It's the sprite coordinate. And self.bounds.y, set that to y. So now everything should start in the right spot, not just eventually get to the right spot. There we go. And we can see where our character needs to be in order to collide with the other stuff. So that's the basic, over a simplified introduction to object-oriented programming. Does it kind of make sense? Y'all on the Zoom call, any questions about that?
Yeah, like I said, it's a lot more simplified and concise. Doesn't have so much going on all at once.
Yes, look at how many lines I'm deleting here to get rid of all this stuff that's commented out, because we don't even need it anymore. It's like, all right, those test cases work. So my recommendation for the little bit of time we have left, about 45 minutes, see if you can do that with the coin. I'm getting ready to put this on GitHub, so if you're trying to follow along or just listening and watching, you're gonna do this later, you'll be able to download this code directly. See if you can do that, turn that coin into an object the same way we just did the player. And also, that sound seemed a little out of place whenever that was the only sound in the game, right? Go download a song, right? Some random song to play or something, and see if you can get some background music playing. Because just the same way we search for the sound effect, y'all know how to find music. The internet's full of music. There's more music than sound effects. I'll leave that one on there because that still belongs to it. There's just showing the background. We'll replace that. Already deleted some things from there. That was from earlier. And I'm gonna now I can erase that to-do comment and clear off that under source. The to-do list is now empty. So that is something that comes from the Python language. The programming language is no to-do comments, and that's a useful thing going back to what we did earlier. So I think that all deleted correctly. Yep, kind of like it was, except that if we generally don't need to see the bounds except unless we need them for debugging. So that line can just comment on and off as needed. That'll work. I'll put this on GitHub real quick. So I stuck it on a code repository. I was expecting it to be near the top. Oh, there it is. SDEV 148 fall 2022. Upload some files. And these two were from today. There we go. Copy, and in the chat room, if you want to copy this real quick. Oh, whoops. That was a direct message. Let me try to send it to everybody. There you go. So there's a URL in the chat room. If you copy that, that's where the class examples are gonna be all semester long. So my GitHub repository. Repositories aren't just online storage. Like the name here, GitHub. Git. The first part of the name, Git, that's an instruction we put in our terminals or consoles, the operating system control language. Every terminal, shell, console, anything like that knows how to do the command Git. So it's more than just online storage when we're in a repository. But there's where the examples are. So if you were following along and might have got a little off, or if you were just watching and gonna do it later, you can download that example. See, you can get some background music there playing, so that sound effect isn't just out of nowhere. And turn the coin into an object. Those would be very, very useful things, good practice with Python. Otherwise, that was it on the list for today. As always, until 3:50, I will be sitting around waiting for questions to come my way because this time should be blocked off on your schedule to learn game development, right? Otherwise, does anybody have any questions before we wrap up? Okay, as always, if you have any questions, send them my way. As always, during the semester, the only two things that make noise on my phone are text messages and the Ivy Learn inbox messages. Anything else I will see before long, but those are the only two things that actually make noise on my phone, which is always in my pocket. If it's not in my pocket, it's because it's late at night and the phone is sitting on my headboard. Otherwise, I will see you all on Wednesday. Have a good one.
You too. Thank you.